Host fan.
Because it's free internet.
I see a recording button in the top right of my screen
Okay, now I have started to record. Okay, so this is fine. Then when it goes, I have no idea. I need to find out when it goes, and then I can just later share it with the other students. But we have 20 students right now. So as far as the way that we have to make the classes, give me just what is your really problems, what would be your problems if it's just really this way. Are you happy? So just, I want to see the feedback first, because that's my goal, to make the classes right on the same time and record it and post it online. But still, the videos that I have posted online, that's just the best way to study. I mean, you can't count on my videos by itself. That's why I have sent extra links for you to practice.
Honestly, for me, YouTube has been my go-to teacher for a lot of semesters.
Okay, so did you check, Peter, the one that I have posted? That I like those videos. This is just really organized and great with one of the professors. Actually, I think Steven is using for a long time. If you can just click on the video that I have posted, and then that would be the perfect and complete way of studying for the course. And this is in addition. The one that we are making right now is just because of the interaction. Because if you have any question, you can stop me. And obviously, it would be, I guess it would be more than 1 hour and 50 minutes, because of the interaction, because of the technology problem. So it should be a little bit longer. If you are planning to be with me on this time, so you have to plan to be more than the usual time of the class. Make sense?
Yes.
Yeah.
Any comments?
Professor Leonard is definitely a good YouTube video to watch. He's got a lot of them, and they are kind of lengthy, but he explains things really well. So it's a good supplement to these videos.
Mm-hmm. Any other comments, guys?
Yeah.
I'm going to turn off the video because I'm sick of looking at myself.
I do have a comment.
Please.
So like I have class like right after like 10:50, so like at 11 as well. So like how long do you gonna go after the usual time?
Do you know whether he's making or she's making the same as us? Because we don't have to be exactly right on the time. We can just make it any time. So unfortunately, I don't have any just certain answer for that one, because it depends on how much technical problem we have, right? So we might have nothing.
Yeah, because like I have right after this class is like another class online as well. So yeah.
Does he do exactly like same time or no?
Yeah, it's through Zoom as well. It's like exactly like 11.
Oh, that's great. That's a great idea. Okay. So what I suggest you is just really, because as you see, I'm recording. So you can just really, whenever you feel is just the time for the other class, leave this and then join to the other one, and then come back for the, probably, I will say at most half an hour more. So just for the other half an hour of the rest of video, or just whatever is the lecture, you can come back and see the recorded one. Is that fine?
Yeah. All right.
Who was talking? I should just guess from the voice, huh?
It's me.
Who?
It's hi.
Hi. Okay, you were talking. Did I reply to your email?
I think no. I sent you an email, so I thought you would be
okay.
something.
No. So it's fine. Okay, as you see, everything is fine because it's recorded. Okay, so the goal is to be exactly on this schedule, because we don't want to have too much pressure at the end of semester. All of us, we want to be on the time that we have scheduled, and later when we get to the end of semester, so there are some students, they want to graduate, they have plan ahead, so we don't want to just mess up with any schedule. And we have really, I think, good tools available to use it. I don't think there is any problem. So you can always come back and record, look at the record one. You don't have to be here right at the time that I am, unless you have a question. If you have a question, please be here on the time, then we can have interaction and we can just explain everything here.
Professor, did you see my email?
I saw. Yeah.
You saw my email last night? So
Yeah.
is it okay?
Yes, it's okay.
It's okay on website?
It's okay, and then I will just do it. Okay, so yes, it's okay.
Oh, so you would do it for me?
Yes,
like...
yes.
Okay, thank you.
If you are here, please always use the audio. Sorry, the printer is calling. Is the voice too much for you?
No, you can adjust it.
Well, that was the printer working.
No, the voice is fine.
Okay, so if you can just always use the voice to talk, that would be great, because it's hard for me at the same time to talk and read. I see some of you wrote something here. If it's any question, can you please, Sylvia, are you fine? Do you have any question? Anyone else? Victoria?
I don't have any questions. I just like meeting in person better. Even though the YouTube videos are really helpful.
I know, yeah. Me too. I really prefer to see you. I will miss you anyway. Okay.
Well, I'm gonna come to class every session regardless, because I don't want to waste my money I spent on the parking and stuff like that. So if you guys want to come out, I'm gonna be here, and we can all do stuff.
I'm also gonna be here.
Wow.
Really? Who was the other one? Ken, you are there?
I'm also here every Thursday because I have lab right before this.
This will probably be the safest place too, because nobody's going to be here, so nobody to get disease. So.
This is good. Okay, so however you feel just really comfortable, and then you can do your job, that's great, but make sure you wash your hands, you clean every place when you put the staffs. But as you said, there's not much students, so it's a little bit safer than to be, I think we have 60,000 students.
I wear gloves all day. I'm going to steal some gloves tomorrow. Oh, shoot, sorry. I'm going to mute the mic.
Is there any other questions? Anyone? Go ahead.
I have a question. I just joined a couple minutes ago. How are we going to deal with the exam?
That's a very good question. We will find out tomorrow afternoon when we have a meeting with the dean and the chair department. So those are the best persons that they can suggest us something. As far as the quizzes, I know I will make them online. I won't have any problem with the quizzes. But for the midterms, there are 2 more left, and then we have the final. So I haven't decided anything. I have no idea what's just the process. But I'm going to just get some ideas tomorrow from our dean to see what they say, okay? So one option is the take-home test, but take-home test works for upper level classes. For calculus classes, as far as I know, take-home test is nonsense. But we will find out, okay? So just wait for me. I will send an email. I think we have about 2 weeks to the next, or 3 weeks.
I think it's the week next week, I think.
Yeah, this is just 2 weeks. Yeah, exactly. Okay. The 2 weeks, in 2 weeks in the Thursday, we have it midterm. Right. So as far as the schedule, I don't want to touch anything, because that's just really convenience for all of us. If we want to change something, and then I might get email for some confliction for the other classes, I don't want to just change anything. We will find the solutions tomorrow, and I will let you know.
Okay. Yeah, I'm okay with a take-home test.
As I said, that's not the solution for calculus classes. Usually it's for upper level. Yeah. But that's just really different level of questions if it goes online or at home.
Right. Okay, sounds good.
Any other question, guys?
I think that, or you open the microphone on both iPad and your laptop, so it's kind of have an echo.
Seriously? Yes. But this, oh no, you know what? This is on mute, the iPad, okay? So what I need to do to turn off the voice, because it's just...
What you can do is you can plug in earbuds or something that has a microphone.
Give me a moment to see why this is not really. Hold on, please.
Hello, thing.
Hello, hi.
صدای ازش پخش میشه.
Yeah, Sylvia was right. I'm using a pair of earbuds that mine are wireless, but they help cut down on the echo, I think.
Okay, so this is great. It seems I have all of you right now.
Yeah.
Everyone is here, okay. And if I can find out how unmute the iPad, yeah, then I'm fine. What do you think right now? Do you still hear the voice twice?
Yes, there's still an echo. Yeah.
Yeah, it's a little. That could possibly be the connection on it as well. Sometimes connection causes echo.
Hold on, please. اگه اونو قطع کنم که خب اونم قطع. بعد صدای خودم نمیشنم. صدای بچه ها نمیشنم. چجوری؟ Can anyone talk to see what's still a echo?
Yeah, there's still an echo coming from you. I mean, it's not as bad, but it's still there.
I think it's okay. I think that's not
No,
like
it's
gonna
not
be
okay because
annoying.
it's recording.
Okay,
I
okay.
need to find out that because you know what I did now? The iPad is on mute, and then the sound for iPad is closed completely. Okay.
Okay.
And then where the sound is coming? It's coming from iPad. This is coming from here. Okay. If this one is connected, then we are fine. It's already on mute. You see, the sound is coming from this one. You don't want to have this one making sound. It's interesting. It doesn't make on mute here. Why? It's on mute already. But that's not here. You see? This is a problem. I don't know why this is not zero completely. This must be zero. It's making sound here. And I don't know why this is. Can you go to the settings?
You can actually do like group work.
Yeah, I'm doing group work now.
This feel like we can actually.
Is it now better, guys? Can you? Who is checking me? Is it now better?
Yes,
Yeah,
it's
it's better.
better.
Okay, something happening, huh?
I was fine all this time.
Do you hear me on echo or is just really one voice?
This is slight like.
It's still a little bit, but it's okay.
Yeah, it's not terrible.
It's like karaoke room echo, that kind of like. It's not too bad. I think you should be good.
Yeah, I think we should get ready to go to start the lecture.
Okay, so it's just about 20 minutes past. Yeah, I have almost all of you in the lecture. So then Let's say what we want to do today. Okay, so is there any group work about, any question about the group works first? The one which is online, I have received all of the emails that you posted your voice thread assignments. Any question, guys? Everything is fine, huh? Okay. So what's the new chapter? So we have to just move forward to the new chapter, which is just integration of multivariable functions. So as of now, we haven't learned anything about integration, but the good news is integration here is not that much bad. I mean, it's not that much complicated. As far as the formulas, the methods, it's just really calculus 1 level, and then the table of formulas is going to be the same thing. So I can just really move on and then just give you the overview of the entire chapter, what we expect to see in this chapter. We will see 2 types of integration. So one of them is double integral. I try to learn how to write nicely on this iPad. And then the other one is the triple integral, okay? And then for the double integral, we do have 2, I will say, coordinate system. One of them is XY coordinate system, which we call it rectangular coordinate system. And then the other one is what we've seen in other calculus, like calculus 2, rectangular system. The other one is the R theta. Okay, so that's just 2 sections of our chapter 12. For the triple integration, we have more options, and that's just really to make our job easier. I mean, when we go further, we will learn something to make the job easier. And for triple integration, we have 3 options. We can do it in rectangular coordinate, means we can keep x, y, z as it is, or we can move to the polar. So, but the polar in the 3-dimensional has different name. We call it cylindrical. And then the last one is rho, theta, and then phi, which is brand new. We haven't seen this one. None of the letters are just familiar. So something brand new, which we want to cover in this chapter, which we call it the spherical coordinate. So just again, these are the ways that we want to simplify the calculation. We want to have easier job for any of these integration. So that's why we move to the new system. But when we move to the new system of coordinate, we have to just really have the permission. So that's just something that we want to know, what's the permission to move to the new coordinate system. So first thing that we want to do is just double integral over rectangular, because that's the easiest region that we can integrate. So means everything is constant. One thing that I need to remember always, integration over here in calculus 3 is definite integration. What does it mean? Means you don't have the function as a result, you have always number as a result. So means I'm looking always for limits of integration to set it up and then to just calculate what's the last answer. Any comment, any question? Why when I have the pen active, I can't move the slide? Sorry. Give me a moment. When I write on this slide, how do I move it? Hey, Steven, you're using all these slides. Tell me, how do I move it? I have to close this one and then it's moving. Okay. Yeah. And then it stays there. When I move it, the slide, what should I do? Erase them? Go ahead, Sylvia, I'm hearing you.
Okay, what is the difference between the XY coordinate system and the rectangular coordinate system?
They're the same. That's the name of them.
Okay, just making sure.
Then it's coming with me. Please, Brandon.
This is Tyler.
Tyler, sorry.
So is it like everything's exactly the same, but it's like just about what they represent? Like that's what we're thinking about in that instant, or for what?
This is a really good question. This is a really good question. The thing is, we have exactly same shape. We have exactly the same graph. Okay, so it's just really how you said we represent it in different coordinate system to make calculation easier. Right? Exactly. So when it's paraboloid, it's paraboloid. But we can write the paraboloid in x, y, z form. We can write the paraboloid in r, theta, z form. Or you can write it in a spherical form, right? So we keep it in the same way. So unfortunately, when I'm writing something, I don't know why, when I'm moving the slide, that thing is coming with me in the next slide. Do you see, guys?
Yep.
Why that's coming? It doesn't stay in that page.
I'm not sure why it does that. Potentially, you'd have to erase what you write.
Always?
I think you'd have to erase what you wrote in order to go to the next one or something. I'm not sure how that works.
So that takes time if we want to erase everything.
Mm-hmm.
Can you increase the brush size so it doesn't take as much time?
Brush size.
Like, is there an option for it?
Oh, yeah, there is an option. I think it's...
No, even the eraser on my side is just, you don't see it, right? My eraser on my side is just off. It's not, the icon is off. I can't see the icon.
Oh, there's a button in the bottom right-hand corner. If you click on the writing like pen to make it active, there's like something that I could use to clear things. It says clear, and then it deleted everything.
I know, but mine is just off. I don't know why. When I'm writing in this way is off. Let's just click on some. Let's make it whiteboard. Okay, so what I do whenever I want to write something on the what is it, the slide, I don't write on this slide. Okay, so I will just really open the whiteboard and write it on whiteboard. Is that fine? And then I go back to the slide. Is that okay? This is just, at least we don't have that written thing all the way to us. Okay.
Yeah, I think you're the only one who has access to a whiteboard, so we might not be able to write with you, but
I have a whiteboard.
We can see you. Yes, you've got a whiteboard, Peter.
You have, I think, 8, 9 whiteboards over there to write on that, Peter. Okay, so how about now? When I'm moving, do you move? Okay, yeah, this is fine. Okay, so as you see in this page, you have had this process before. What is this process before? When I had to just get you see the whiteboard right now, right?
Yep.
Yes, okay. We do.
Okay, so whenever we want to just get the integration, what we need is just to define what you call integration. So if you want to just get the area under the curve, in calculus 1 we have learned this is the same as just the function is right there, and then you have started to get the area under the curve, and then that's later is called the Riemann sum, which is definition of definite integration, right? So the process is you usually start to chop it to the pieces. So what does it mean? Means you just make this one to more pieces as n is approaching to infinity, right? This. And then you pick a lucky point. I call it lucky point because we have many options. Look at here. So you can just take right endpoint, you can take left endpoint, you can get the midpoint. So these are the options that you have had. So either one, if you pick a point, which I'm going to call it a star or lucky point, then this is the goal, to get this, which is the width, and multiply by this, which is the height or the length of your rectangle, and then the area of the rectangle is going to be the value of your function at that lucky point multiplied by the width, and that just sigma over the number of pieces. So if you add all of this area, you will get just what we call area under the curve approximately. So this is giving you the area under the curve approximately, but since this is just the error right over here, right? So then you have many errors. Then to make that error less and less, you just set the number of pieces to be more and more. So then you just say n is approaching to infinity for this sigma, and that is just really what you called to be your definite integration from a to b f of x dx, right? So think about this process of chopping to the pieces, pick a lucky point, and make a Riemann sum is going to be always the same for all of my listed methods of integration, because I have listed at the beginning 5 methods, just 2 for double integration and 3 for triple integration, okay? So this is the process I want to repeat. Always just chop my region to the pieces, pick a point, and make a Riemann sum and define a new type of integration. So that's really same process. And this is still there. Do you see? That's the problem. This is still there.
That's really weird.
Mm-hmm. Okay. So you know what I want to do? I just right now, I start to do all of my work on the whiteboard, okay? Then you don't see the PowerPoints anymore. So this is just the only thing that I can do right now. So what I do is I will start to write every single, like just I'm in the class, every single thing on the, what is it? Whiteboard things. You see the whiteboard clearly, right? Hey guys.
Yeah, we see the whiteboard.
Yeah, we see the
Whiteboard clearly, okay.
I'm gonna open up the PowerPoint slides on my own screen then.
So no, I will write everything. So then if you want, you write, just take this one, open, that's fine. If not, that's fine. So how do I move the whiteboard? It doesn't move. Sorry. Now this, Steven, do you know how to open the new page on this thing?
I don't know about the whiteboard itself.
You know, this is just a whiteboard, but I just want to move it. It doesn't move.
There might be a, like I can't see your controls for it, but there might be something on the whiteboard that allows you to
this whiteboard, this
clear
is
everything.
Make a new page. That's what I'm looking for. Make a new page. It doesn't move up.
Yeah, so do you have a little pen in the bottom left corner?
Bottom left corner.
Of your screen? If you tap that, you should have like the menu that comes up that gives you pen, highlighter, line, and then eraser and colors. On the far right-hand corner of the screen, it says clear.
But for me, it's off.
Oh, it's off?
It doesn't let me clear. Why? I have no idea.
That's very weird.
It's very weird.
Because I can write on the screen as well, but then I can hit my clear button and it goes away. Is there any reason you can do it, I cannot do it? Do you know any reason for that? Nope. I shouldn't be able to do it. I'm not the host. And even I don't have that thing that usually we have it on iPad. We can just select all and delete all at the same time. That's not there too. It's probably something to do with Zoom software, I think. No, doesn't do anything. Any idea how to go further? But you have the erase button. Is that available? That's interesting. I don't have erase. I do have, but it's not available. The only option that I have say undo, and I do everything undo.
That doesn't make sense. That does not make sense.
Must be something in the settings that
Okay. Let's just do something else. This is what I have right now. Then the eraser is available. Okay, for here, everything is available. Okay. For the new whiteboard that I have opened, everything is available. So what do you see right now, guys?
we see your whiteboard.
And it's blank, huh?
It's blank. Yeah, blank.
I don't know whether this one is moving or what it does, but at least I have a eraser on that. Okay. So as I said, the idea here is going to be, oh, you write something on mine? Who is writing? Steven, you could write that.
I was testing out how
I like that one. I like that one. If you can write on my whiteboard, that's just really great. So you can just really ask your questions by just pointing where is the question easily. This is fine. Okay.
Get my colored pens.
Okay. Are you ready? So this is my main, I will say, structure of why we do the double integration in the way that it is, right? So what it is, you have a function which is a positive for now, but in general it could be any, and then you have a given interval. So this is just a notation for given interval A, B cross CD. So this is just a lazy way if you want to write, I meant to be the part that all x's is limited between A and B, and the y's is limited between C and D. So this is my notation for what we call rectangle region. So this is my rectangle region. And then the goal here is going to be the three-dimensional version of area, right? So if the single integration is going to give me the area under the curve, now what is the triple integration? It's double integration. They are going to give you something in space, right? So the goal here is find the volume, but this time is under something which is in three-dimensional. So three-dimensional is a function of two variables. So basically what's going on over here, there is just a function of z as a function of f of xy. So I just say this is my function, and then that is going to be the roof of the volume that I'm looking for. Then I can just define some region. So this is just between A and B. So what I meant is just really, this is the C for the Y value, this is the D for the Y value, and then this is just the smallest value of the X, so that's A, and then this is the biggest value is the B. And that means really having over here, if I just can make a nice one, so I have started the A to be negative, so it's just a little bit further, and then the C is just somewhere is positive, so it's like this. Okay, so it seems this is my A in the negative piece, this is my B, and then this is my C, and this is my D. Okay, so basically you want to just get the volume of this solid whenever this is the base. Okay, so imagine there is something like a shadow. Your roof is just a surface which looks like the z equals f of xy, but the base is just that thing. So basically what we are doing is just follow the process. What was the process? Chop it to the pieces, pick a lucky point, and then make a Riemann sum. Then that's just going to be what you call a new version of integration, which is going to be volume under the surface. Fine by now. Any questions? Everything is fine?
Could you explain where the Q came from again?
Do I have Q? Wow, what happened? Do you hear the voice?
It's very echoey at the moment.
Yeah, it's really echoey.
There
What
it
was
goes.
that voice coming?
Feedback. Somebody's too close to a speaker.
You can mute your.
I believe that don't put the your iPad and your laptop next to each other, so it's kind of like create that kind of echo. That's why
Okay.
I think so.
I think no, but anyway, that's from me. Even though everything is unmuted, I don't know.
Okay, now it's really echoey.
Okay. You know what? I am going to leave the meeting.
What?
I think she left in order to come back.
Okay. Do you hear me?
Yeah, that's better.
Anyone
Yes.
else?
Yeah, we can hear you now.
We good. We good.
Okay. And then how about the page? Do you see the page that I am sharing?
Uh-huh.
Okay. So Sylvia, what did you ask?
I didn't ask any questions. I went to the restroom.
So someone asked me something, right? So where the Q is coming from?
Yeah, it was
There's
me,
no
Nora.
Q.
I asked the
These are all
question.
A. Am I right? Is it fine? Okay. So as I said, I just want to follow the process of chopping to the pieces, pick a lucky point, and then make a Riemann sum. So first of all, you have to divide this from A to B, this from A to B to n pieces, right? So divide A to B into n pieces. Okay, so this is number one. Because I have two-dimensional region, I have to just do this division 2 times, right? And this means you have started, the smallest point is A, and then the biggest is just going to be the B, and then whatever is between, right? So this is just x sub naught, and this is just x sub n, okay? And that's just for x direction. And then the same thing, I have to just go and make it in CD, right? So you have to do that chopping to the pieces in the other direction too, which looks like this. So this is into the M. It doesn't have to be the same number of pieces. So I divide it to the M sub intervals. So this is going to be step number 1, which I have chopped this thing to this M times N pieces. So this is number 1. And then you have to pick just some points, right? So do you see for the points that we have had only in one dimension, right, left, midpoint, now you can just select this point, which is what? Right down. You can just select this point. Which is up, right, or this, which is left, and this, which is the left down, okay? Or you can just really say, I want to select something in between this squared piece, and that's fine. So the number of points that you can select is just really different. the number of points could be really more than what we have done in just calculus 1 version. But it doesn't matter because this is given in the problem. Which point to select for this approximation Riemann sum is always given in the problem. So let's say you just say, I want to pick the point to be somewhere between, which is the best point. I'm going to call it X star, Y star, because I don't care which one it is, right? So it's just really for approximation. So I chopped to the pieces and I picked now the lucky point. So if I go back to do the same process over here in three-dimensional, this is going to be my pieces or sub-rectangles. And then this is going to be the ith piece that I have selected. Okay, so this is my ith piece that I have selected. So then I go up and I evaluate basically the value at that point. So what would be the value of my function if I plug in X star and Y star? So this is just really the height of this column that I have made. Is that fine by now? Yes?
Yes.
Okay. So this is fx or the height of that column that I have. The goal was to find the volume. So I know what's the volume of any rectangular box is just really the area and then multiply by the height. Area then multiply by the height. What is the area of the base? So this is telling us the width is going to be end point minus start point divided by number of pieces. The length is going to be end point minus start point divided by number of pieces. So then the area is going to be really delta x times delta y. So delta x times delta y. Now, if I just want to define what we call integration, basically, which is make the Riemann sum, you have to evaluate your function, which is height of that column, and then you multiply by area of the base. And then since we want to have better what is approximation, you just say, okay, so let's say this number of pieces is more and more, this number of pieces is more and more. What does it mean? It means they are approaching to the infinity. We usually use 2 sigmas because it's just one in x direction and one is the y direction. So that's just 2 sigma notations. And that's exactly is the best number for volume under the surface. So to find the volume under the surface is just defined to be double integration of f of xy dA. And then the limits of integration is really that rectangle region. I'm going to make my rectangle region one more time over here. So that was just the rectangle region. And this is going to be x, this is going to be y, and that's just chopping to the pieces. And that is just the region of integration, okay? So to find the volume under the surface, I need a double integration, but it's really important to know what's the region of integration. And that's just really the base of whatever you are planning to get the volume, the base of that. And the roof, the top of your volume is just making your integrand. This is the top of the surface is going to be your integrand, and then you are integrating over that surface, which is a function of 2 variables. Any question by now? Do you have any question?
Can you go back to the previous page?
Yeah.
Okay, thank you.
I'm hoping all of these are recording, and if not, because it's repeated in the afternoon for the other class, I will find just the technical issue that I have, and then I can just record it again. But again, the best way just to review all of them is, first of all, to be here on time. If not, go back and just watch the recorded one, okay? Don't worry if you couldn't catch up, but still you can ask me to go back. Is there any question? Move on?
Yep.
Okay. So just to one more time to remind you, whenever you have had the single integration, which is here, same thing for double integration, And then for triple integration, the way that we do actually the problems are not really this Riemann sum, adding things. It's just really a table of formulas, right? So integration of cosine is negative sign. Integration of, sorry, cosine is positive sign. Sine is negative cosine. Just there's table of things that we have learned in calculus 1, and it's really same thing. This is just to give you the concept. This is to give you the concept, what the concept is. To find the volume on the surface, you must get the double integration where your integrand is going to be the function and the region of integration is going to be the base of that things that you're trying to find. So just to practice one example, I just write down one of the example that we have in the lectures, and that's just telling us, again, I will write every single detail, okay? So example says, estimate the volume. In a case you don't have that slide open, I will just write every word here. And estimate the volume of the solid that the base, it says lies above. The base is that 0, 2 for the x, 0 to 2 for the y, and then it's below the parabolic shape. Okay, and then every single information is given. What it is, it says divide to 4 equal pieces. Okay, so means n and m, both of them are 2, which 2 by 2 is making the 4. And then what else it says? It says to have your lucky point, select the upper right corner. So select the upper right corner. Of squares. Okay, so these are given information for us, and the goal is to use that 4 actually squares to approximate the volume under that paraboloid, right? So let's say, do I remember how to graph this z equals 16 minus x squared minus 2y squared? Let's just check to be copied correctly. So this is going to be the previous slide. Yeah. So it's 16 minus x squared minus 2y squared. And then the area is from 0 to 2. Okay. So if I don't remember, I must really, there is no way to skip these graphing things for the rest of the chapters. So the first thing that I need to remember, this is going to be a paraboloid. And then the next thing that I need to remember is going to be upside down because of these negatives, because these two are negatives, is going to be upside down. And that's just going to be the highest point, right? So because this is starting from the highest point, so this is going to be the highest point. So then I'm going to make this paraboloid right over here and say, is upside down paraboloid starting from 16. And then just to make sure I know these numbers, which is the intersection, it's nice to know what happened if you set the z equals 0, because that gives you the how tall or how big is this portion, because you need this portion. Okay, so then I will say this is going to be 16 equals x squared plus 2y squared. So divide by 16, divide by 16, divide by 16. So that is going to be x squared divided by 16 plus y squared divided by 8. So that tells you in y direction you have 2 rad 2, which is the square root of 8. And in x direction you have 4 units. The only reason that I made that numbers, just really to know when I'm looking for 2, is just really here. right? This is 2 and this is 2. Okay, so this is 2, this is 2. Approximately, it's not really nice graph. Why I'm looking for the 2? Because the region supposed to be between 0 to 2, right? So that's just the square. Oh, okay. Peter, I think we can stop just right. Is that fine to finish this problem? So let's just finish one example and then stop. Okay. Thank you, Peter, for reminding me. So you can just be time recorder for me. Always remind me. So then what I said is I have to first of all start to chopping to the pieces, right? So I need to know if this is just going to be my region, which is from 0 to 2, which is from 0 to 2, and it's supposed to be 4 pieces. Why? Because the question asked me. So that's the number always given in the problem. So then I have to just say, okay, chop to the 4 pieces is really 4 equal squares, and that's just the numbers. And the problem asked me upper right corner. So this is upper right corner, this is upper right corner, this is upper right corner, this is upper right corner. So those are the points. So the coordinate is 2, 2. The coordinate is 1, 2. And then the coordinate is 1, 1. And then the other one is 2, 1, huh? So those are the 4 sample points, lucky points that you need to take from the squares, right? So from this, oops, no. From this square, I have selected the right corner. From this square, I have selected the right corner. From this square, I have selected the right corner. And from this is just this right corner, okay? So that's step number 1. Step number 2 was, sorry, pick the point was step number 2. Now you need to just get, okay, what's the height of the columns? So what's the value of the function at 1, 1? What's the value of function at 2, 1? What's the value of function at 2, 2? What's the value of function at 1, 2? Huh? So those are your, height of each column. So that's just really plugging in the original function, so which I'm rewriting over here. So this is my function 16 minus x squared minus 2y squared. So this is the function. So it's just going to be 16 minus x squared minus 2 times of 1. Then this is going to be 16 minus 3. So this is 16 minus x, which is 2, minus 2y squared, which is going to be, giving the number, 10. So this is going to be 16 minus 2 squared minus 2. Then this is 2 squared. So that is how much? 2 times 4 is 8. Minus 4 is
7.
7 left, huh? No. Yeah. 16 minus, and then 1 square minus 2 times. Then I have 2 square. So this is 16 minus 7, which is, what is left?
7.
9, no? 60 minus...
minus 9 is 7.
So 7 left. So the top one is wrong, huh?
The third one, I think it's 4, not 7.
Yeah, it's just 4, right? Okay. And these are the value of the function. I'm going to really show you what's going on over here in this graph, right? So if I have this chopping to the pieces, this is going to be something like this. For every single one, so for example, let's say you are at the point of 2, 2, 2. So the value at 2, 2, it seems is just 4 units. So it's just the shortest box. So this is just going to be my box, which is too short because it's really 4 units. Okay. And then the next one is just 7 units. So where is the 1 and 2? I will say 1x, and then y2 is just 1, 2, right? So 1x and 2, so it's just going to be 7 units, a little bit bigger column, a little bit bigger, so it's just really 7 units down. And then the next one is 2, 1, so 2 in x and then 1 is just right there, and it's, what is the 2, 1 is 10 units. So I will say it's a little bit larger. I go up because it's 10 units. Okay, so that's just for 2, 1, and the last one is 1, 1. So the 1, 1 is just the tallest column that I have, so I just make this is just a little bit bigger. So what's going on, I'm adding these numbers, right? So it's just really adding the volume of these colorful columns to get the volume, but it's really not a good approximation because the number of pieces is 4 and it's not really enough. Okay, so to make that Riemann sum, which we call it f at that lucky point, and then multiply by area, which is really fun here because area is just really 1. This is your delta x and this is your delta y, so that's just really 1 unit in each direction. So then if I want to write the delta a is just width times length, which is 1 times 1 is 1 unit, and that's just adding this number, right? So you have f at 2, first one is 1, 1, 1 times delta a. Next one is 2, 1 times delta a, and then the next one is 2, 2 times delta a, and the next one is 1, 2 times delta a. So this is going to be 13 plus 10 plus 4 plus and then 7, right? So that's 34, and that's just really not good approximation. Why this is not a good approximation? I can just again go back to the graph, say, okay, so if supposed to be volume, this should be this much big, right? So if this is the volume, it has to be this much the top, then you have really this many errors, and then right here is your error. So you have so much errors, and then in this section we will learn how to do or how to get the exact value, but that's just telling you how you chop into the pieces by the number of given in the problem, how you pick a point, but again given in the problem, and then how you add every single volume of these little columns to approximate your volume under the curves. Okay, is there any question here? Someone should say something. Is there any question?
Nope.
Nope.
Okay, so since we need a break, so let's just make a break. I know it's just really doing one problem in 1 hour, but that's just going to be better. Okay, so I promise you it's going to be better soon. So for now, I don't know how to make it up. So if anyone is going to leave, let's just make it how many minutes? 10 minutes is okay?
10 minutes. Okay, I'm going to make hibachi. I'm getting food.
Okay.
I can get food from that 10 minutes.
So just, you mean it's a lot? So make it 5 minutes?
Oh, no. I can go
Okay, so let's just make it 10 minutes. I'll be back in 10 minutes, okay?
Okay.
I mean, I'm here. I don't go anywhere. If anyone wants to add anything, you can add it. But otherwise, I won't teach it, okay?
Okay, I'll be back.
Okay, I will play with this.
How long is the break again?
10 minutes.
10 minutes, 10 minutes, Tyler.
An hour?
10 minutes.
Okay, okay.
Can I ask a question?
For sure, yeah. If you don't want to ask about the in this problem inside, I just want to see, I'm playing with that. Is that fine? Ask and I'm listening, okay?
Okay. On the bottom, where you had written the delta A, when you were adding for the Riemann sum, what is that delta A, and like why, like, is that a number or is that just, I know it's like this area.
It's yeah, delta A is always the area of the pieces, so it's just the area of the pieces. So for ours, the pieces was those little squares. So those little squares has the area with width times length, which is delta x times delta y is 1 times 1, so it's 1. So that's why we didn't plug in. That was the mistake. We should plug in.
Yeah. Okay.
Anything else?
No, thank you.
Okay, now is gone. Sorry, guys. When I close this one to play with this, now I can't bring the same page again. Let's bring always the new page. Where does it say?
Is it just me or is the screen white?
No, I make the screen white. I was just, I'm searching because now I just want to show you something in three-dimensional, a nicer graph in three-dimensional. So I'm searching whether I can just do it at the same time. How do I bring both slide and whiteboard in same page? Steven, do you have any idea?
No, the only way that I know you could do that would be to, I mean, you can share your screen, but I think that's only if you're up on the lecture slide.
If I share my screen, so it's really you on the screen because you're talking, but no, it doesn't show both pages, huh? I want to.
No. Yeah. I mean, the only way that I know you could probably do that is if you somehow took a screenshot or a screen snip of the lecture slide, and the whiteboard allowed you to paste it on there. But I don't know how to do that. I don't even know if that's possible.
So let's see if I go to 250. I didn't take the time. Who's taking the time? So it's now 5 minutes gone. Okay, so we have about 5 minutes to play with this. 5 minutes. How many minutes? 5. 5 more, right? Now. Yeah, I said 5 more, right? You're right. So far, how do you like this type of lecturing? I think Tyler loves, right? He can just lie and do it.
Watching the lecture from your bed? Yeah.
Yeah, Tyler, that's just...
Actually, I moved to my desk, so it was easier to write.
Yeah.
But it is nice being in my bedroom.
Hey, you're saving time. You don't have to drive, right?
That's what I thought. I don't have to spend half an hour finding parking or whatever. You can just wake up right before class.
Yeah, it's same for us. I mean, not parking was the issue for me. Then Steven helps me because he told me that valet parking helps me a lot. Then, but driving still is a long time.
Yeah, I still personally like being in class. There's something about being in class that makes it better for me. But this isn't too bad. I'm learning.
Turn this off.
I like the way which is very informal. I'm an informal person. I can't be formal, never ever, right? So I like the way that we can talk about anything, and at the same time there is a time that we lecture. I like that way.
Maybe we should stop doing VoiceThread and just do it this way. Eh?
VoiceThread has a limited time, so we can just record on VoiceThread only 5 minutes.
Oh, really?
Mm. Or I don't remember the number exactly, but it's really short time. It's not a big time.
This seems like this seems to be doing what VoiceThread wants to be doing, but they can't do because it sucks. So yeah, this seems like a better method of doing whatever discussions, you know. Just a thought. I mean, you know, if you want to cancel with VoiceThread, I'm not going to complain.
No, I like the VoiceThread. The way it is, I like the VoiceThread because the grading is easy because it's connected to the gradebook. All right. So for this one, it's not connected to the gradebook.
Oh.
So how do I grade people who are doing the job?
I'm sure there's a programmer out there who can figure this out for us in class, you know. So.
I have because I'm just really closely connected to the IT people. I have searched because what's your reason to ask? Can you tell me what's your reason to think about this way? Because VoiceThread is just doing the job as
VoiceThread. Once we do the assignment, you know, there's no real interactivity. You just leave a comment after. And I noticed like most people just say, hey, you did a great job. And there's no real discussion going on, you know. So here, at least we can kind of discuss stuff.
Then think about because then in this case, you have to have, individual discussion for individual problems, right? So for example, if I have a problem number one, group of number one, so who is going to attend at a certain time to discuss about a certain problem? This is the problem. So what is it, Sylvia? Sylvia is just saying, so what's the Sylvia? Can you tell me?
I'm on the laptop and I tried using the snipping tool. So that's something that you can use to take a screenshot of the entire slide and then you can write on the side, but it does not have an undo function.
That's exactly because I've seen Steven always doing such a this thing. Steven always is just cut a PowerPoint and then copy somewhere else and then start the writing. That's why I'm just constantly bring your name because I remember you have done such a this thing.
Yeah, mine is coming from my, like I can screen snip my lecture slides and then I can paste them into my notes, but I don't know if it's possible for me to paste them into Zoom. I don't know if it'll allow me to paste it into a whiteboard there. That's my.
I don't think, will it let you annotate if you don't paste it into Zoom?
Yeah, if just this slide somehow give me I will find out soon. Okay, so don't worry. I just have a meeting with my IT people and then I will find it soon. But what it is just really make it the same way that Steven usually takes the note. Just make this slide smaller or side note for me, and then I can write it beside of that. I don't know whether this is because I have opened the PowerPoints. If I just open in something else like a PDF, it lets me to do something more. That's just really another question.
Yeah, I'm not sure how that. I'm not sure how that can work.
This is the 10 minutes is gone. Okay. So what I do right now is just showing. Do you see the page? I mean the PowerPoints that I'm sharing right now.
Yes.
Yeah, we see those.
Okay. Can we continue? Everyone is ready?
Yes.
Okay. So this is just telling us that numbers that we have selected only to be 4 squares wasn't really nice approximation. So I'm showing to this slide to remind you, if you remember, if you make these pieces more and more, you will have better approximation. Okay. So here it is 4 times 4. So this is 16 of those volumes, sub-volumes. So that's just really one better approximation than 36. 34 because we got number of 34 for the calculation that we have done before the break. And then here, if you see, it's just really 8 times 8, right? So when you have 8 times 8, so that's a better approximation, which is 44.80. And then this is 16 times 16. And you see it takes that type of shape, which is supposed to be like a paraboloid shape. When you have this more number of pieces, and that's just really better approximation. But this is really the exact value. So then when you do the integration by the methods, by the formula, that's the 48. So that's just telling us, okay, if you keep going and make the number of pieces more and more and approach to infinity, you will have better approximation. And that's the idea of what we call Riemann sum, okay? Now it's interesting because this clear bottom is available, okay? So we can go and continue on this one, but this doesn't move. Yeah, that does move, okay. We can continue on this one, right? Okay, this is my second example. Why it's here? Because to just remind us, first of all, in chapter 10 and in chapter 11, we have worked with the graphs. That's just really adding one more concept here in chapter 12 to say, okay, so if you have this thing, which is basically volume under the surface, you don't need to know that much about Riemann sum. You don't need that much about the calculus 3, as long as you know this is giving you the volume, as long as this is just really the volume, and then as long as you can graph this region, you should be fine. But what I need to remember, this is just the top of whatever I supposed to find the volume. So then chapter 10, chapter 11, we have had many examples which we graph this one. So main thing is, what's this graph? That's, I'm looking for the volume under that graph, right? So what is the equation and what is the function and what is the graph of this one, which I'm looking exactly for the volume under the curve, right? So volume under this surface. So when you look at this problem, you say, okay, I don't have any idea. This is supposed to be output letter z always as a function of xy equals square root of 1 minus x squared. So then this is something that we've seen, but not in this format. We've seen it in standard form. So then I just start to square both sides, and then you just have to make it in standard form. Yes, I've seen this one. I haven't seen this one, but I've seen this one. I know how to get this one, okay? So this is going to be what? Anyone remember what's the graph?
That's
No?
sort of like a circle, right?
In 3 dimension?
Or
cylinder?
It's a sphere.
Sphere has z square. Yes, Sylvia, is a cylinder. Why? Because it's a cylinder. Because
Y
you
is not
have
defined.
the y is
yeah.
So when the y is not there, which means the y can takes every variable from negative infinity to positive infinity, basically means is stretching in the y direction, right? So this is telling me is stretching in the y direction, and that's the circle with the radius of y. Anyone knows why I made it half, not the whole thing?
Because it started out as half. Like as, hold on.
Because of the square root there, the radical.
Exactly. So then you have had, if there was entire cylinder, it has to be plus minus, but it's not, right? So this is missing my pen. So this is plus minus, right? So that's not plus minus. For my problem is only plus. Plus means only the top, right? So that's just the top half of my cylinder. That's only the top half of my cylinder, okay? So that's why I made it half. That's why I made it half. Otherwise, it has to be entire one. The other thing that you need to know is the region of integration. So if this is a cylinder, and I have learned in geometric, the volume of the cylinder is going to be pi radius square times height. So that's why I have the region of integration right there, right? So the region of integration is going to be -1 to 1 for the x direction. That's just really what it is for the radius of my circle. And then I have from negative 2 to the 2. So then I have from negative 2 to the 2. So what is the height of this cylinder? 4. Yeah, thank you. This is nice that you can just participate to every single part. So then all I need to solve, I don't need to know integration. I don't need to know double integral. I just need to know what's the volume of the cylinder. So this is half of the volume of the cylinder. Why? Because it was just only the top half. And then this is going to be half pi radius, which was 1 times height, which is 4. So then that's the answer. You're done, 2 pi. Okay, so you don't have to know anything about integration. So that's telling us the concept. Concept of the double integration is volume under the surface. Which surface, whatever is your integrand, is the top or the surface that you're just graphing, basically. Make sense?
Yep.
Okay, move on. Any question here?
At some point in time, will we learn how to evaluate this one?
Right now, yeah. That's just
Okay.
today. Any question? Okay. Now I have the clear bottom. Then I can move this one. This is perfect. So this is just same thing that I have explained all the way. So I'm just moving fast. Then that's just another example. Example number 3, I'm not going to try, that takes time, is really practicing what is the Riemann sum one more time. And that's just nice because it's only for four pieces. So I'm going to skip this problem, and it has a solution right there. It's just one more Riemann sum. So let's just say about this slide, what it is. Whatever properties that we've seen in calculus 1 for integration now works here nicely. How does it work? So if you have integration of, addition of the function, if you need to split it out, do it, that's fine. Integration of addition is addition of integration. If you have any scalar and you need to factor it out, you did it in calculus 1, was fine. Here in calculus 3, constant, you can bring it out, okay? And the next one is just whenever you have inequality, if you have inequality, you can integrate both sides. It doesn't matter is a double integral both sides. It doesn't matter is triple integral both sides. It doesn't matter is single integration both sides. So inequality, it's fine to integrate both sides. This is a really nice property. Remember, when we have inequality, we have to remember it changes if you have any negative sign, right? So it changes if you multiply or divide by negative. It seems integration doesn't do it with the sign. That's why it doesn't change at all. However, is the inequality stays exactly the same thing, okay? Make sense? That's the property. Then, so yes, this is just the thing that we need to know for calculation. How do we find integral by Taylor formula? Is really the same thing how you have done differentiate, right? If you can just differentiate partially, we can integrate partially too, right? Integration partially is the same as differentiate partially. So whenever you're trying to just get the integration in terms of something, the other thing has to be constant, like exactly partial derivatives, right? So this is partial integration. If your goal is to integrate in terms of the y, so first thing is x is fixed. So x has to be a constant, has to be a number, and then you do your integration all in terms of the y. And then since, as I said, we don't have indefinite integration, so everything is definite, you have to plug in the limits and get it. So table of formulas stays exactly the same thing. All of the methods of integration, we use substitution, integration by parts, is exactly the same thing. I need to just remember I'm doing partially. Partially means, so you fix the x and you integrate in terms of the y, okay? So that's, as I said, is called partial integration. It says it's called partial integration, okay? So we can take 10, right? So we can partially integrate in terms of the y and then partially integrate in terms of the x, or it's just really do it step by step, right? So how do I know which one is first? It's just really the way that the integration is writing, right? So let's just say this is one of them, all right? So this says, based on the order of integration that we've seen for years in algebra classes, inside is first. So that tells you you have to start with the y first, and when you're done with the y, you can just move to the x, right? So this is just how we do based on the order of integration. Parentheses is always first. So whatever is inside is first. So this means I have to integrate in terms of the y when x is constant, and then when I'm done, that's just doing with respect to the x. Is it fine? Okay,
and it
so
doesn't matter which one is on the outside, and like, it doesn't matter if we switch the dx and the dy.
As long, that's a very good question that we want to answer in the next theorem. As long as when the y is there, this is the limits for the y, right? So as long as when you switch the order of integration, as long as you keep the limits by itself, right? So if you just make this one to be outside, so you have to move the CD to be outside and then the AB to be inside, right? Because that's just different, right? So these limits are for the x, these limits are for the y, okay? Yes, you can switch the order of integration, and that's what we do many times because we want to make whichever is easier first. Sometimes in terms of the y is easier to integrate, sometimes in terms of x is easier. So we switch the order only if we just have these limits in the right order, okay? Make sense?
Yeah.
That was a good question, thank you. And let's just clear and then move. And the title or the name for this one is iterated integral. So we call this one iterated integral, the way that we do it by order. First in terms of x, then y, then x. That is called iterated integral, okay? And then we can do in any order. That's just the answer of your question. So if you have dy, then dx, you can make it dx and dy as long as you remember you just change these limits to whatever is with the x is with the x, whatever is with the y is with the y, okay? But you can do in any order, whichever is easier. That's what we do first. Fine?
Yes.
And that's reminding us always order of operation is inside to the outside is really same thing. So we can now practice with these problems. This is just a good question. I think there's a typo. We can fix it when I'm doing. So I will write the first one first. Okay. Part A. You have this inside. So that means you take care of that one first, right? So you take care of that one first. So you just have integration from 0 to 1. And then you have dy. Okay, so this is, for now, we just leave it as it is. The outside, we don't want to touch it because we are taking whatever is inside. So can you just really think about what would be the derivative, integration in terms of the x when y is a constant? So one more time, integration of ax dx was ax divided by a. I just call it e or whatever. Okay, so you divide by that constant, huh? So what's the integration of e to the negative 2x? So it's e to the negative 2x divided by negative 2 by that formula. But the y cube is a constant, so we have to keep it. Does it make sense?
Yeah.
Okay, so as we keep the y outside or constant, this is just same thing that we have done in calculus 1, right? So we need to evaluate this thing. So means you have a negative half, you have e to the negative 2 times 2, e to the negative 2 times 1, and then that's dy, okay? So these are all from here to here constants. So if they are constant, I can just bring it out or factor it out. I prefer always to factor this constant out. So that's going to be negative half. That is going to be e to the negative 4 minus e to the negative 2. This is it. And then I integrate from 0 to 1 y cubed dy. This is calculus 1. I don't have any problem with the next step because as long as I take care of my inside, then I'm just in calculus 1, right? So however you prefer, you just make this one e to the 4 minus e to the 2. And then here is the 10 for the y, which is just simply y to the 4th divided by 4, plug in 0 to 1, and then you are done, right? So it's really simple. If I remember, it has to be partially integration, and it has to be in order from inside to the outside. Any question?
Nope.
Good.
Delete it?
Yeah.
I
Ready for
just
the
need a
next
second to
problem.
finish copying it down.
Print screen, homie. Print screen.
We have started, you know what? We have started with 29 students, now 18 left.
Maybe somebody lost their internet connection. Just thinking positively.
So we need to see what would be the recorded one. If anyone can test it later and let me just have any feedback, because we have.
All right, we're good. We're good to go. Or I'm good to go, I should say.
Yep.
No, I don't see that much. You didn't see. I'm hearing you. No worries. Okay, so I'm erasing this one, and then let's see what's the difference between B and B. Actually, because they are the same problem, that's why it's B and B. It is first take care of dy, so which is 0 to 1 dy and then 1 to 2 dx, huh? And that's the same function. And the next one is 0 to 1 d. Y is outside, so that's a typo. And 1 to 2 dx is inside to be the same. Okay. So these two are the same problems. Do you see? So you have integration from 0 to the 1 dy. This is 0 to the 1 dy. And then you have integration from 1 to 2 dx. And this is 1 to 2 dx and the same function. Okay. These are exactly same problem. So we can see which the order of integration. Can we think which one is easier to do? Is it easier first integrate in terms of y and then in terms of x, or is it easier do it in terms of x and then in terms of y? Any idea?
In terms of y first.
Yeah, in terms of y should be easier.
It should be easier because if I do in terms of x first, I have to do integration by parts. I'm too lazy to do that one. So I do the first one first, right? So this is just really what you need to remember, okay? So the order of integration is always on your hand. You can reorder it whenever you want. And that's the theorem. It's called Fubini's theorem that lets you just always to change the order of integration. Whichever we choose is whichever is easier. Right, so whatever is easier to faster, or just you don't need to use that much techniques of integration. So that's just what you need to use. Okay, as you said, the first one, because it doesn't need to just do integration by parts, we just do the first one first. So this is outside, which I just keep it as it is. So for the inside, I have to take the integration in terms of the integration in terms of the what? Y, huh? So x is a constant. One more time, if I remind you, that was e to the constant times x dx is going to be itself divided by the constant. So now is itself divided by constant. What is my constant now? When I'm integrating in terms of the y.
X is your constant.
So then this is your x, the constant, right? So this x, not this x. This x is canceling out exactly. So who is typing? I don't see who's typing. So then it's just going from 0 to 1, right?
Yeah.
That's just really the great things that this can be simplified easily. Then the next step is just probably easier with only one variable. So this is going to be e to the, this values was for the y. Don't forget this is just plugging for the y. Okay, so then x left, right? So you just have y minus e to the 0. Is it okay? Did I plug in for the y? Yes or no?
Yeah, that's good.
E to the x minus
E to the x,
e
huh?
to the 0, which is 1.
Okay. That's it. So the next step is just really what we've seen in calculus 1, because it's just really single integration of e to the x minus 1 dx, and I can integrate it by e is itself, this is x, and plug in 1 to 2, so that gives you e to the 2 minus 2 and minus the next line is e to the 1 minus 1. So I have e to the du minus e to the 1 minus 2 plus 1, huh? It's minus 1. It's not bad. It's not really, integration is not bad. So as long as the limits of integration is given to me, as long as I can decide which way is easier to do, is it dy dx or dx dy, so you should be fine. But the most, I will say, problems that you might have is just really see the graph, because since you need to graph it, so that's just what we need to practice more from chapter 10, chapter 11. We have done many, but if you don't remember, we need to just really practice again. Question here?
Nope.
Okay, move on.
Yes.
Sure.
So this is another example over here, which is different. Okay, so that's what I said. And then actually Silvia asked me too, this is the name of theorem. Fubini's theorem is the theorem that lets just really, whenever we need a reorder of the integration. So you can have dA, if you don't know what's the order, is it dx dy or dy dx, you can have dA. But if you want to just really decide later whether you like to just, or easiest for you to do dy dx or dx dy, this is for the later, okay? But just remember, if you are reordering this integration, this goes with the limits of integration, this goes with the limits of integration. Don't leave the limits as it is, right? So you move everything and you switch everything, okay? So that's just what we call Fubini's theorem. And it works for any dimensions, right? So we've seen it in calculus 1 in single, and then now it's calculus 3, 2 or double integrations, triple integrations, or n integrations, n-dimensional integration, it works, okay?
So when it comes to double integration or more, we can choose which is easier to do, and the order in which we do it gives us the same answer?
That's Fubini's theorem. As long as your function, that's just, as long as your function is continuous, okay? This is the main condition. As long as your function is continuous, that works.
Okay. Does that work the same way if we have to do like use substitutions and changing our bounds? We only stick with the one part of the integration that we're actually doing?
Yes.
We don't, okay. We don't touch the outside until we're done with the inside.
Exactly. I have another similar problems that's just we need to decide, as you say, is given to be dA, so means I don't know which order is better, right? So it's given to be the dA, so that's just really you to decide, do you want to do dy first or the dx, then dx dy, so that's up to you. Which way?
I think doing dx first would be better.
Mm-hmm.
Then you get rid of the y.
Exactly, because that's, if you do it dy first, you have a product of two functions. Product of two functions in terms of y, you have to do integration by parts. It's not bad, but we don't like to just do it as much as is possible, huh? So that's why you just have to keep it in the same way, and then try to do it as Sylvia said, dx dy, okay? And that's the limits of integration is given to you. So the order that, as we said, this means the first one is the limits for the x always, the second one is limits for the y always. Okay, so this is just different ways of writing the limits of integration. Okay, so if you are ready and then you have decided to do in terms of the x, so the outside is the y. What's the limits of integration for the y? 0 to pi. What's the limits of integration for the x? 1 to 2. So then you have y sine of xy, and then you have to take care of inside first. You keep the outside as it is, and then what's this in terms of the x, when is y constant? So y is a constant. So sine, integration of sine is?
Cosine.
Cosine.
Oh, yeah.
Okay.
Negative cosine.
So one more time to remind you, the formula says sine of ax dx is negative cosine of ax divided by constant. What's my constant now because I'm integrating in terms of x?
Y constant.
Okay. So then you plug in the values from 1 to 2 for the x's, huh? So this is going to be integration from 0 to pi, y by y cancel out. So go ahead to just do whatever you do. I mean, if you are adding the lines or notes for me, this is perfect, okay? So always you can ask or write on my screen. So this is going to be this time for the x's. So let's just plug in at the same time. We don't need to rewrite the problem again. So x's was 2y cosine of, what is the next? Y, huh? dy. Is it fine? Move on, right? So this is now integration of the cosine. So let's just remind you one more time. Cosine of ax dx is sine of ax divided by constant. So cosine is sine. Cosine is sine of 2y and divide by constant,
which is 2.
And then one more time, that's just plus sine of the y, and then you have to plug in the values, right? So minus sine of 2, everything is 0, huh? Do I need to write it down? No, right? Because sine of 2 pi is 0. Let me write one more line, and then I can just stop. Sine of 2 pi divided by 2 plus sine of pi minus sine of 0 divided by 2 plus sine of 0. And everything is 0.
Yep. Okay.
Any comments? Any question?
I don't have any comments or questions, but I need to go to a different class now, so I'm gonna listen to the recording of this, but this class requires me to be in person, so I'm gonna have to go now.
Perfect, thank you.
Bye.
I have a question.
Please.
Where did you get the negative cos 2y plus cos y dy?
So this is the place, right? So this is the place. So we have to plug in x values over here, right? So this is x equals 2 to the x equals 1, right? So these are your endpoints, which is just really your fundamental theorem of calculus, which says if you have f of x dx, and then you go from a to b, you have to plug in f at b minus f at a, okay? So that's what I've done over here. So you have had x equals 2, I plug in for x to be 2, so then I have minus cosine of 2y. Is that fine?
Yeah.
Do you see?
Yeah, I see that.
Why I don't have nicer color? Or highlighter, okay. So then this is going to be here, which I plug in for 2, and here we should plug in for the 1. Okay. Any other question? Move on. No? Yes? So this is it. One of these, and you can see, actually I have done the other way in these slides. I'm not going to repeat it, but if you are interested to see what's going on, if you do the other order, what's the other order? The long one, the one which just said we don't like it, right? So what it is, if you first do with respect to the y, and then with respect to the x, this is a long way, because here is product of two functions. Product of two functions is going to be integration by parts. So this is in the slide, I'm not going to cover now, and I don't expect you to just do it in that way, but that's good to remember what was the integration by parts, because we've seen it for calculus 2, but that's just really the longer way, which we said we don't prefer to do it. And that's just to remind you one more time. So to evaluate double integration, you need to be wise to choose the order of integration, which is simpler. So that's just what I'm looking for. It has to be simple. Whatever is simple, we like it. And it works in either way.
Simpler is better, especially if it's on a test.
Yeah, okay. So this is, I have to erase it. Okay. This problem is exactly the same problem we have at the first example, and that says you should, what is it? Approximate for only 4 pieces. So it says, how about if I want to approximate for more pieces, and then how about if I want to get the exact value, which I use just real integrations, right? So this problem is really same problem. If you don't remember, I can just write what was the problem. So z equals 16 minus x squared minus 2y squared was given as a function. So limits of integration it was given for 0 to 2 cross 0 to 2. And the question asked us to make it in 4 pieces to approximate, and then we got actually really bad approximation, because we got 34. We got 34 in that problem number 1, or example number 1. Now we can get the exact value. This is the time we can get the exact value. So let me just erase this one. This is reminding you this is the same problem, and say, okay, if the problem is given to me in this form, how do I get the volume? I can write it in steps, but that's just really, I need to remember always, if I don't see the graph, I don't know what to do, right? So for now, what is the main thing is just, this is giving you the limits of integration. This is giving you the limits of integration. So if I just start to graph this one, which I have done actually in the first example. So this is just a paraboloid, graph of the paraboloid, which is z equals 16 minus x squared minus 2y squared. And then that is going to be paraboloid upside down. And the highest point was 16 because of this number is 16. And then we just got in this direction, it has to be 8, square root of 8. And in this direction, it's going to be 4. That's the number we found in the first example at the beginning of this record. So then the question asked me start at this plane of, so I need my highlighter or just make the color differently. So this is going to be when you just have y equals 2. This is when you have y equals 2. So the plane of y equals 2 is right there. So then I can change it to the color maybe green and make the plane of x equals 2. This is the plane of x equals 2, which is parallel to the yz plane. And then the other coordinate planes, so it's just really limited to the coordinate planes. So I have stopped there, which is limited to the coordinate plane, and this is the coordinate plane, okay? So the blue one is up there, the blue one is up there, it's just your coordinate planes. Do you see? Is it fine? Okay. So that tells me actually I have to find the limits of integration, which is this rectangle region, So then I just say I have to go integration of what is my function? What is the roof, or what's the function here is no idea? What's the top?
The top is your equation, isn't it? The x squared plus 2y squared.
Exactly, the entire paraboloid equation, right? So it's just entire paraboloid equation, right? So I'm going to start from, if you let me erase this part and then start from the top because I don't have room to integrate. So I start from here. So in the volume that we supposed to get, so the volume that we're supposed to get is going to be double integration of f of xy and dA. So as you said, that's the function. 16 minus x squared minus 2y squared dA is the function. That's the roof. This is the top, all right? So then I have to know what's the limits of integration. This is nice over here, actually. What's the limits of integration? So limits of integration, this is just the x, right? This is just the y. This is x, this is y, okay? So if I want to write the limits of integration, it's going to be integration from 0 to 2 in x and integration from 0 to 2 in y. Does it matter which order we go? It's
No.
polynomial, right? So polynomial in either way is just going to be un or power rule, right? So for all of them, I just need to know integration of x to the n. Peter, you're fine. You can go. We've been too slow, guys, but I will finish this section and I expect you to watch the videos that I have posted, okay? So as I said, the goal is not to be behind of any schedule and keep the track as we're supposed to be in the class time, okay? But if anyone is leaving, you have always the option to go back and just find these recorded videos, or just watch the videos that I have already linked it on the titanium. Okay, so either one is fine.
Okay, bye-bye.
Bye. And then you don't have to be here right now unless you have really questions, okay? But I really prefer to hear your voices and have interaction. Otherwise, I can just record the videos as and send it, okay? So then there's no interaction. So since it's a time to be available, as much as you can make the time, just to ask question and make it interaction, and then you can just make sure you understand everything, and then double check with the videos. Okay.
You said you're gonna post it on Titanium, right?
I believe the way it is, the way that is setting, it will be automatically there, recorded. Okay. So whenever you go to the meeting and click on that, it should be recorded already, and it's still recording anyway, right? So I'm hoping nothing missing. If something is missing, I will check for the afternoon, because it's repeated exactly same. I will check it in the afternoon to see what it is. Okay. But it will be there, always available. If for some reason you miss the time, then you will miss the interaction that we have right now. Otherwise, the topics is just covered in the video that I posted online and in these lectures.
Okay.
So this is available for future reference.
Always, yeah.
Yeah.
We hope so.
Is the voice recorded as well?
The voice thread?
No, like what we're speaking right now, or what we're saying, is it recorded as well?
I think so.
Okay, all right, because that would make some topics clear.
No, I think so. Yeah.
I don't think we have permission to record though, so.
I don't think it's available now, right? So this is what I figured out from the testing thing that I made. Since when I finished the meeting, it takes about more than 2 hours where I got the email that your meeting is recorded and is saved somewhere. So then if you need it, just bring it, save it. So that's, I think it's not recorded right away. It has to be after a few hours. We will find out, okay? So,
okay.
But that's a goal. That's a good goal to have it, okay? Should I continue to integrate?
Yeah, you can finish it off.
Okay. So then I have integration of integration from 0 to 2, and then this is the 10. This is the 10 for the y for now, because the y is inside. So what's the integration of 16 in terms of the y?
16y.
What's the integration of x squared in terms of the y?
X squared y.
And then what's the integration of y squared in terms of the y?
2/3 y to the third.
And that's it, plug in. So we have had 16 times 2. Then we have had x squared times 2. And then we have had y cube. Do you agree with me? I don't need to plug in 0 because everything is 0.
0, 0.
Okay. So then now is the 10 for the x. I can just integrate in terms of the x. At the same time, when I just have the 16 times 2 is 32x. And then this is 2x cubed divided by 3. This is 8 times 2, which is 16 divided by 3. But integration in terms of x is just x 0 to 2, then whatever, right? So you can just plug in x to be 2, x to be 2, and then x to be 2. And then 0 is 0. All is 0, you don't need to write it. And that gives you, actually we had the numbers, we can just check, it was 48. So this is the first problem that we have approximately find 34. Now it's 48. The exact value is 48. Do you have any question? Should I move on?
No, I think that's it.
Move on, guys.
Yeah.
Okay.
I mean, that's about wrapping up our time as far as our hour and 15 goes.
I know. So this is one thing that we have had, but as far as the schedule, seems I have to continue for the next section. Actually, because you are behind comparing to the other class, we can do a few things, right? So I can just email to everyone and make sure you are watching the other videos that I have posted, or I can just maybe give you a bit, maybe break and continue the second section. For the other class, actually, we are in the second section. This is just what we will start in this class, which is the second section, because we have started the first section. But anyway, I meant to just say we are behind. So anyway, I have to just do one more section. I can do it right now, or I can just make the break and then do it just during the weekend for you, or make just a little bit maybe extra session somewhere in next week to make sure we are on the track. What do you think?
Yeah, well, I know that like a lot of people have other classes they've got to go to. They probably won't be able to hang around.
I know. Right now it's
And
impossible
with all,
for me.
with
I'm
the
tired.
yeah, with the
I can't stand.
extra work that I'm going to have with all my other classes, I don't know if I'll be able to have time to watch a section 12.2 over the weekend, because I've got a lot of other homework from other classes I still have to do as well, as finish up what I have for this class. So it might be better if I can, we can try to work it out to be a little more streamlined next week when class meets up again.
Plus, we have those videos to watch too, the YouTube videos. It's like 6 hours of that.
Yeah,
You
it's
don't
just a
have
lot
to.
to.
So you can
Lot
do
to watch.
either one. So remember, if you have that videos is just alternative, right? So if for some reason you couldn't get to this class, always you can watch those videos. If for some reason you prefer to always hear my voice, so you can only watch my videos. That videos is extra, okay, to help you more. But I will recommend strongly to watch it. Recommend just. The thing is, the break time, the spring break time is going to help us, because as long as there is no class, so I'm just going to continue the classes. But if we just have 2 hours only one lecture, so that's just really not the way that we do in the class. So it should be 2 hours, 2 lectures. So I mean 2 sections to cover. So for, as I said, for now, I can't talk anymore too. So then we stop right now, but we need to find a solution for, because your class is behind. For the other class, I will start to 12.2 and then 12.3. So we need to catch up to the other class because we are one section behind. But I will email everyone. Okay, so for now, let's just not worry about that thing. And thank you for joining, and thank you for just being interactive with this class. I love that thing. And just please keep going. The classes is there. If anyone wants to be in the class, it's fine, but that's just for now. And give me the feedback, okay? So I'm waiting for your emails. If you have anything that doesn't work, technical problem or any other feedback, I'll wait for your emails, okay?
Thank you.
You're welcome. Anything else?
No, I think we just have group work to be done, and then we have a new group work for next week.
I think the things that we have still is on chapter 11.
Group work 7.
Yeah, group work 7 is due tonight.
And then for the next week, from the next week actually, for every single section that we cover, there is one group work, because it's just really like a derivative. If you practice, you will learn. If you don't practice, it's just really more practicing on the group work. So I think for every single section, we have one separate group work. So again, since we want to keep everything on the same schedule, we don't want to change anything. I think we need somehow to cover the extra section, but I'm going to check what's the due dates for the group work number 8 and 9, to see what should be.
Yeah.
Okay.
I think group work 8 is due on March 17th, so next Tuesday, according to the Titanium right now.
Okay.
But only the individual turn-in is up. There is no, like, I don't see I can't even access the work for
Okay, no worries.
that section. So.
Okay, no worries. We'll just set it everything up, and then I will email everyone to see what's the best to do.
Right, sounds good.
Okay, guys, have a good weekend, and then let's see what we can do better. Just I'm waiting for your feedbacks. Okay. Thank you. Bye.
All right, thank you so much.
Right.
Have a good weekend.
You too. Thank you. Bye.